In this video, we will be talking about measures of position. The first measure of position that we already talked about, and you may want to watch the previous video for an example. However, we will go over an example in this video. So that first measure was called the z-score. Here is the formula associated with the z-score. We will be talking, and I'll give you another example in this video. Then we will be talking about the quartiles and the percentiles. The z-score is actually how many standard deviations a value is from the mean. The formula for the z-score is the data value minus mu divided by sigma. And you do recognize right here the symbols for the population. So this would be the parameters. So this z-score refers to the population. And if we want to change this and write this formula in terms of a sample, you'll simply adjust those two values. It's x minus x bar divided by s. The quartiles are very important measures of position. And these dividers, these are actually called quartile 1, quartile 2, and quartile 3. Split the data into 4 equal parts, which means we have 25% in each part. That's the reason they are called quartiles. A great visual for this will be, well, imagine the data is arranged in order from the minimum value to the maximum value, or the lowest to the highest, okay? And you are dividing the data in half. Right here you will find quartile 2, which we know is the median. But then look at the first half of the data set and continue the process. Divide this in half. The median of the first half is actually the first quartile. The median of the upper half is the third quartile. You have 100% of the data right here between these two values, which means on each one of these parts, you have 25% of the data. Okay, that's why these are called quartiles, and hopefully this visual helps you understand this definition. Now moving on to percentiles, we are repeating the same process. So imagine repeating the same process right here, but instead of splitting the data in 4 equal parts, you'll split the data in 100 equal parts, because these dividers, and we call the percentiles P1, P2, and so on up to P99, split the data into 100 equal parts. So you are actually left with 1% in each part. So I'll let you try to visualize that, and we will move on to the next slide. Let's go over another example for the standard score. You will find an example on the previous video, and here is the definition followed by another example. The standard score, the z-score, represents the number of standard deviations a given value x falls from the mean. We talked about this formula. Just make sure whenever you apply the formula, the value x comes first, and then you plug in the mean, and on the bottom you plug in the standard deviation. So the example I was referring to is right here. Two students, John and Ali, from different high schools, wanted to find out who had the highest GPA when compared to her school. We have the information for John listed right here in this table. We see that his GPA is 2.85, the school mean GPA is 3, and the standard deviation 0.7. While Ali, he has a GPA of 77, the school mean GPA is 80, and the standard deviation of the school is 10. So let's take care of the z-score associated with John's value. John has a value that will be an x. So right here, we have the values for x, and right here, we have the mean. And right here, of course, we have the standard deviation. Because we're talking about the schools, we will be looking at that as population, and we will be using the appropriate notation. So for John, I have 2.85 minus 3 on the top, and on the bottom, divide this by 7. So for John, if you do this calculation with a calculator, you should get 0.21, negative 0.21. While for Ali, now let's find the z-score for Ali, we have to follow the same process. 77 minus 80 divided by 10 this time. And if we do this correctly, our result, it will be negative 0.30. Now this is Ali, and right here we have John's result as a z-score. The question was, which one did better? All we have to do is to compare these two numbers. Keep in mind these two numbers are negative. So the one that did better will be the one that is closer to 0. You can visualize this on the number line, if that helps. Okay, but hopefully you will agree with me that the one closest to 0 is actually negative 0.21. So John did better. And here we have the result and an application of the z-score. So let's take a look now at quartiles. I did explain how to find quartiles. This is what is written right here. Find the median or the second quartile first, then find the first quartile by looking at the middle value of the lower half of the data, and find the third quartile, which is denoted Q3, by looking at the middle value or median of the upper half of the data. I gave you a visual a few minutes ago, so let's continue and practice with this. I have an example right here. Listed are the 10 ages for Academy Award winning Best Actors in order from smallest to largest. We have the data right there, and we will find the quartiles. Here we go. Now, for practical reasons, I picked only 10. I don't want to spend too much time on this one, but you actually have the example with more values, more data values. The nice thing about this one, this is already ordered for us. Just make sure if it's not ordered, you have to first order your data set. So now to find the quartiles, I will simply look at these values. I identify which one is the minimum, and I will actually put it down right here. The minimum is 18, and it's easy to identify the maximum. The maximum is 33. And now I will simply split the data in half. I have 10 values right here. So 5 to the right, 5 to the left, or I can just simply cross out the data until I get to the middle. However, the middle right here seems to have, because I have an even number of values, it seems to have only 2 values, right? So I will not really have a median, an exact value, which is a data set. So it will be in between. It will be 26.5. So this will be actually the median or the second quartile, and I'll put it right here, 26.5. Now I will split the data in half to find the first and the third quartile. And my first half of the data is actually based on these 5 values. And right here in the middle is really easy to see that I have number 22. So that will be the first quartile. I will do the exact same thing with the half or the second part or the upper half of the data. Right here in the middle, I have number 30, which will be the third quartile. Most of the time, right here, the second quartile is actually called the median. The first number is called the minimum, and the last number is called the maximum. And what we have right here, we have very important numbers, which are measures of location, called the 5-number summary. Very important, 5-number summary. So I will write down quartile 1, which is 22, and quartile 3, which is 30. Let's talk a little bit more about these numbers and some direct applications. So here is an important measure that we will be using to solve some applications of the 5-number summary. This is called the interquartile range. What is the interquartile range? It's actually the difference between the 2 quartiles, quartile 3 and quartile 1. By the name, interquartile. in between quartiles. You simply take quartile 3 and quartile 1, subtract those two, and you'll find the interquartile range. Now, if you think about this, you will have actually 50% of the data between these two quartiles. So make a note of this. Interquartile range is often used to describe the spread of the middle 50%. I have the values from our previous example right here. So this is the minimum. This was the first quartile. This was the second quartile or the median. This was the third quartile, and this is the maximum. So to find the interquartile range for our example, well, I will simply subtract these two values. So subtracting these two values, I have 30 minus 22. So the interquartile range here will be 8. So how do we use this value to help us identify outliers? Here it is. A data value X is considered an outlier if either X is less than this quantity, which is quartile 1 minus 1.5 times interquartile range, or X is greater than this quantity, quartile 3 plus 1.5 interquartile range. So I will quickly copy down the quartiles right here from the previous example. And if I remember correctly, the first quartile was 22 and the third quartile was 30. And the interquartile range was 8. And that's all I need to figure out outliers. Quartile 1, 22 minus 1.5 times 8. If we do this correctly, our answer will be 10. And the other one is actually 30, plug in the value, quartile 3 is 30, plus 1.5 times 8, and that will be 42. So all we have to do now is create an interval from 10 to 42 and state that any data value outside this interval will be an outlier. Any X outside this interval. So if we want to inspect the data, go back to the data, and we're looking for outliers, we have to make sure that our data is in here. Otherwise, that will be called an outlier. I'm back at our example. I have the interval written down right here, and I inspect my values. Do I see any value that is outside this interval? Well, it seems that 18, which is the lowest value, is in this interval. 33, which is the highest value, is also in this interval. All the values in between belong to this interval. So based on this and the work that was shown before, I have no outliers. Using the calculator to find the quartiles, we will simply enter the data in one of the lists. If you choose to enter it in list 1, that's fine. If you choose to enter it in a different list, that's fine. But you want to make sure when you do the one variable stats, after you click on stats, calc, you want to make sure you will enter the list where you have the data. And then you'll simply have to scroll down because the 5-number summaries are the last thing on the screen. So this is how the calculator should look like. Now, if you have a TI-83 to look like this, and you'll have to enter L1 by doing second one. If you have a TI-84 plus, it will look like this. Make sure you have no value for the frequency list and just hit calculate. And now let's take a look at the visual display of the 5-number summary. The 5-number summary can be visualized using what we call a box and whisker plot, or simply box plots. A box plot is a graphical representation of the 5-number summary and is constructed as follows. First, construct the horizontal scale spanning the range of the data. Now, I've seen box plots that are drawn using a vertical scale, and that is okay. Then plot the 5 numbers, and you want to make sure you use an appropriate scale for these numbers, and these numbers should be plotted above the number line. Then you will simply draw a box from Q1 to Q3 and draw a vertical line in the box for the median or Q2. The last step will be to draw whiskers from the box to the minimum and the maximum values. Here is an example. We have the following data, and you see there are many values. I believe we have about 12 values or more. I'll invite you to use a calculator or do this by hand and try to find the 5-number summary. And if you do this correctly, these are the results. The minimum is 1, the first quartile is 2, the median is 7, the third quartile is 9, and the maximum is 11.5. So to construct the box plot, and we already have the visual right here, simply put these values on the number line, and then around the first quartile and the third quartile, you will simply construct the box. These are the first and the third quartile. You will make a note that right here you have the median, which is the second quartile, inside the box, and you will simply extend whiskers to the minimum. This is the minimum and the maximum. You can get so much information from this graph. First of all, make sure you realize that this box displays the spread of the data for the middle 50%. And it is the spread around the median, not around the mean. Moving on, we will be talking about percentiles. Let's look at the following example. John scored a 28 on his ACT, which gave him a 78th percentile. What does this represent? If you think of this and you are trying to visualize what does this mean, you do realize that this score, John's score, will be situated somewhere around here. You have 78% of the data below his score and 22% of the data above his score. So the 78th percentile is a measure of location. It tells you where this score is located. There are two types of problems. One problem is given a percentile, find the data value. And the second type of problem will be given the data value, find the percentile. And that's the reason we have actually two formulas. Let's take a look at each formula and go over some examples. In this situation, we are looking for the kth percentile. And here is the formula that will help us find the kth percentile. So when you look at the formula, you have to make sure you understand what each variable stands for. You'll have to know, and this is very important, that I will not be the answer. I will be the location of your answer. You're looking for a data value. I will tell you where it is. You'll have to count and get your information from there. K, well, K is the percentile. So the percentile is given. And N is the sample size. So here is our example. We will plug in the formula and we will answer these two questions. These data are the 29 ages for Academy Award winning Best Actors in order from smallest to largest. So we want to make sure, and this is very important, that this is in order, okay? This is already in order for us, so here we go. First of all, in order to do this problem and try to find these percentiles, first we'll start with this one. Let's make sure we know what K and N are, and then we will plug in. So first of all, K is 40 because it's the percentile, and N is 29. So I will simply do to find the location of this 40th percentile. I'll just simply find I by using the formula. So I will do 40 over 100 times 29 plus 1. It will be 40 over 100 times 30, which is actually 12. Again, keep in mind, this is the location. What does that mean? Well, that means all I have to do now is simply count the 12th value. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 37. So the answer to the first problem is the 40th percentile is 37. Let's do the next problem. And right here, we are looking for the 78th percentile. 78th percentile. So I will repeat the same process. I will be using the same formula. In this case, K is 78 and N is the same, 29. So I equals 78 over 100 times 29 plus 1, which is 78 over 100 times 30, which is 23.4. Now this time, I is not an integer. Where do I find this value? What is the location? Well, if something like this happens, you will simply have to go between the 23rd and 24th value. And this is exactly what we're going to do. So I'll simply count to the 23rd value, and hopefully I'm not mistaken. It is 69. The 24th value is 71. So I have two values right here, and my 78 percentile will be in between. I'll take these values and I will simply find the average. And the answer is 70. I will say the 78 percentile for this data set is 70. Our second and last formula is the percentile equals x plus 0.5y divided by n times 100. So this is a type of problem when the value is given and you are looking for a percentile, for the percentile of that value. So let's look a little bit of this formula and try to understand how it works. What is x and what is y? And n we know is the sample size. So I'll just write it here, but I'm more curious about x and y. X is actually the number of data less than the data for which we find the percentile. What is y? Y is the number of data that is equal to the data value for which we find the percentile. So is the same thing that I wrote up there. So I will use this notation. That means everything that I put down there should be copied here. So let's see how does this work. For example, here is our stem and leaf plot. We have the key right here. This is the weight in pounds of carry-on luggage on a plane. Find the percentile of 24. So this is a data value, and we have to find the percentile. As we inspect this data, it is already in order, which is great. So check order first, and then let's go ahead and try to apply the formula. I'm looking at where 24 is. Well, I have 1, 2, 3 values that are 24. And I'll write down the formula, and I simply have to come back here and see how many data are less than the value. How many? I count all data values less than 24. That will be 6, 7, 12, 15, and so on. So how many? I'll just simply count the leaves. 1, 2, 3, 4, 5, 6, 7. So x in this situation is 7. Then I have to add 0.5 times y. Y is how many data values are equal to our value. Well, we have 3 values that are equal. Many times you'll have only 1 value, but in this case we have 3. So we'll just simply multiply that by 3 and divide by the sample size. We have 28 values in this sample. So this is actually 8.5 divided by 28. So it will be the 30th percentile. And the answer is 30, which means the answer to this first problem is the percentile of 24 is 30. The 30th percentile will be corresponding to the value of 24. Now find the percentile of 41. So let's just practice now with 41, and we will do the exact same thing. I'm looking at 41. Well, 41 is right here. It's only 1 value. So I will simply count how many values are below 41. I'll repeat the formula. I got 23 values plus 0.5 times how many values of 41 do we have? Well, it's only 1 divided by the total number of values, which is 28, multiplied by 100. So what we have here is 23.5 divided by 28 times 100. So our percentile will be 84. If we round to 2 decimal places, this will be the 84th percent. This concludes this video.